Okay, so today I'm going to talk about a restoration framework that a collaborative group of scientists, including myself and a whole list of other researchers that are named there, have been working on the upper Gila River in eastern Arizona, trying to tackle a complex restoration approach to about 50, 60 miles of river. All right, so there's a very strong need for restoration at the Gila Watershed Partnership of Arizona, first identified, and they helped bring us in to answer some complex questions about the environmental factors influencing and also have the potential of being affected by any sort of riparian restoration in the corridor. Dense tamarisk infestation, just like many of the systems we've been talking about. Here's a picture of the upper Gila River. This is between the towns of Safford and Fort Thomas. If you're familiar with the area, that's all tamarisk, very difficult to walk through. The leaf beetle is not here yet. If you remember from any of the maps that we've seen yesterday, the beetle is poised to colonize probably within the next few years. Lots of food. And currently it's very important, it is identified as important habitat, and I'm not a biologist, I'm a geomorphologist, but I hear that it's very important habitat for southwestern willow flycatcher, yellow-billed cuckoo, and many other listed species and other native species. What I am interested in is how dynamic the river is. So this is a hydrologically and geomorphologically very changeable river, mostly an unregulated system, no dams, and is prone to frequent channel resetting events. This is the very simple conceptual model of our approach. How do we gather all the baseline information to make informed decisions about the best possible strategies and priorities for restoration in the corridor? The first step, of course, is to develop the restoration framework. The next is where in this big, long riparian corridor along 50 miles or so, and sometimes 2,000 width of river corridor, where do we apply restoration? We can't do the whole thing, and we don't want to do the whole thing because there are sensitive species to consider. So where can we best apply and put our money? And then the next, of course, is to establish monitoring protocols. The beetles aren't here yet. Let's take advantage of that and start monitoring the vegetation, do some pre and eventual post biocontrol monitoring, and then restoration success monitoring, and then, of course, implement the actual restoration. Next. Okay, lots of information was considered here. And I'll list, this is kind of an overview of all of the information and approaches that we integrated. It began with remote sensing. That was a critical piece. We can't look at the entire river, so we worked with our partners at Utah State University. They flew over the entire river. Actually, they flew over about 100 miles because they considered other portions of the system as well that could be considered in the future. LiDAR data, color, multispectral imagery. The next piece is what I'm really going to be talking about today, and that's what I worked on and my colleague Bruce Orr worked on. That's the eco-hydrology assessment. And a pointer. All right. So, sorry, the second point is really what I'm going to be focusing on today, and this is really the core of our framework to synthesize all the available information to identify suitable sites and priorities. A big piece of that, which was very novel in this approach, was working with Jim Hatton of the USGS, where he applied his swivel breeding habitat suitability model. There were a few talks yesterday that referenced this. I think this is just genius. I'm only going to briefly touch on that, unfortunately. Site surveys and biocontrol pre-beetle baseline monitoring in strategic locations, mostly to validate and prepare for eventual implementation, and general technical input and coordination with the Watershed Partnership. So again, I'm going to focus primarily on the eco-hydrology approach or assessment, and this is where we're going to boil down to identifying suitable sites. Okay, again, a big area, hard to wrap your head and hands around. So let's focus on some strategic locations. First, identifying, well, where's the riparian corridor? That's easy. The next is consideration of flood scour potential. We don't want to recommend restoration in any areas that are likely to get blown out, essentially in the next flood. Vegetation character, the existing and potential growth opportunities. Water availability, which is tied into that. And that's what I'm talking about there are shallow side channels with shallow surface water, shallow groundwater. Soil salinity. And then this is Jim Hatton's swivel habitat suitability, which gets plugged into here, where we ultimately end up with identifying the suitable locations for restoration. Where are we in the world? This is a corner of the eastern Arizona, upper Gila Watershed, which goes out into New Mexico. And we are focused primarily in this green area. Next. Okay, so we're at the mouth of the Gila Box, past the town of Safford, Pima, very good cotton growing region, past Fort Thomas, and down to the reservation boundary. We need to understand the flood dynamics through here. Now, we're not talking about overall water delivery. We're not worried about where flooding extent may go. We ultimately want this information to get to geomorphic activity. So here's a compilation of 5 long-term gauges in the area, going back to the early 1900s. And you can see that there have been periods of larger intense floods in the early 1900s, then a calm period, and then a very large period. What the future holds, we don't know. But either way, we expect that any year, whether it's winter or summer in the monsoons, a large event could occur. So what we want to do is focus on 3 of the most recent floods to inform on potential future activity: 1983, 93, and 2005. We also want to consider the general geomorphic trends through the reach. As we come out of the Gila Box, where there actually is a decent mosaic of cottonwood willow, coarse sediment, we have a fining of sediment. We also have a change in vegetation. And I know I'm talking about geomorphology, but it's all wrapped in together. And there's Tom Dudley out there in the river. So I'm going to show you a series of the 3 of the most recent flood events and how we incorporated those to identify where the changeable areas of the river are. This is 1983. This was a 100-year event. This was a massive event. We're not likely to see this anytime soon, but it could. Thank you. Oh, right. Okay. So I just want to show you some quick repeat views, and then I'll summarize briefly what we did. But we want to interpret where the scour areas are from these floods. 1993. And 2005, which was a much smaller flow. It's about a 10-year event. So we digitized tediously in a GIS the occurrence of scour that occurred in those 3 events. And what we have here is occurrence of where there was scour in all 3 floods, or all 2 floods, or all 1 flood. And we identified a flood reset zone. The red areas are where there was scour. Again, this is geomorphic activity in all 3 of those events. We want to recommend avoiding those areas because they're most likely, what we believe, to be most likely to be scoured again in the future. Okay. The other areas, there's of course other areas that could as well, but these we're using the past essentially to inform on the future. Next. All right, now let me move on to the next. Okay, LiDAR. So part of the remote sensing data that we had collected, we are using it to not only look at the bare earth, which I'll get to in a minute, but also the riparian canopy. So from the LiDAR, we actually have a surface for the top of the canopy, okay? And we also have the bare earth. And from this, we can get a better beginning of understanding what sort of structure is out there. So this is ranged from bare earth up to about 10 or more meters. That's where we can pull out the cottonwoods. I'm just going to skip ahead here. So then this is a piece that Utah State worked on, where they were, from the multispectral, able to interpret the dominant vegetation types. So in purple, we have tamarisk, and in the greens, we have the native willows and cottonwoods. That's a very good baseline to begin with. It's not entirely accurate, so one of the things we need to do is do some spot transects out there. And we had our botanists go out and do 23 transects. Here's 3 of them. Transect plot surveys. And I'm not going to go through all the details here, but a general list of all the information that was collected at these transects, estimated time since the last flood, various other physical attributes, and of course the dominant vegetation types and groups and alliances. And the reason why the other attributes are being collected is because we want to understand how they're related to the physical environment. The groups and the alliance at the level that were characterized based on the U.S. National Vegetation Classification. And here's just an example of 2 of the dominant native groups. But again, I want to point out how it relates to the physical attributes of the area so that we can understand how to inform on restoration plantings and planting services specifically here. So frequency of occurrence of this group, there it is. In red, cottonwood, blue, willow, Gooding's willow. And these are relative elevations. So within 4 meters is where we see the distribution or the occurrence of this native group. Okay, so this is going to inform on, well, for within 4 meters of the low flow channel, that should be a suitable planting. Now that actually sounds like a lot of height. It's about 12, 13 feet. So If we look at mulefat and narrowleaf willow in the bottom plot, it's about within, the grouping is up to about 3 meters. So 3 meters was a good guide. So we need to focus our native plantings within that area, which is obviously intuitive, but good to see. Okay, I'm going to skip down to the findings. This is a conceptual view of one of the cross sections. There's variation, of course, along the length of the river, being that there's greater density as you move downstream, which is probably a product of the diversions that are occurring in the valley, but also at the mouth of the box where the flood forces are strongest. There's less vegetation density, and of course there's a variation along the width of the channel. They observed a limited natural recruitment of native woody vegetation. Most of the native stands, we're talking cottonwood willow, seem to be about 20 years, so that coincides with the 1993 flood event. Of course, avoid the flood reset zone. There was some recent scour, even this September, where some established sandbar willow was being observed to be removed. Take advantage of existing native stands, propagal island approach, either by expanding those stands and also creating new islands implemented, which could essentially occur almost anywhere. The tamarisk growth is so intense that it should be, the productivity potential for the native plantings should be good in most places, and that's a general observation. I'll get to the refinement in just a minute. And then take advantage of recent burned areas. Okay, moving along. Water availability. How do you figure out water availability along 53 miles of river? Let's go back to our remote sensing information. This is a relative elevation. So this is relative from the low flow channel. The blue is the low flow channel, 0 to 1 meters, and everything color graded above that. Okay. Red being the highest areas above the channel. Is this a good proxy for estimating shallow water, either surface water or groundwater? And we hypothesized yes, but we need to validate that. And so Kevin Holtine of the Desert Botanical Garden and his field assistant Dan Kepke went out and installed a series of piezometers. Here's 2 of them. He's installed 10 of the 13. We don't have all the data yet, but let's make a quick comparison of what he measured in the field compared to what we would extract from the LiDAR, from the relative elevation. And long story short, for each of these stations, there's 10 of them so far, the average difference is about a foot, which we think is actually pretty good. So that validates the use of using the relative elevation information to generally characterize or anticipate where there would be shallow groundwater. So again, for planting suitability. All right, this is an ugly map, but we want to factor in salinity as well. And we don't have enough field data of soil samples. They're still forthcoming. So for now, we're looking at what's available publicly from the NRCS. And this is a really hard to look at map, but the general point is that there really aren't any moderately or saline patches. As a joke, you have to take this with a grain of salt because this is very coarse level mapping, and if you were to get down to an actual plot where you're replanting, is it appropriate? Maybe, maybe not. But I think the point is that the salinity doesn't appear to be an issue. All right, now this is Jim Hatton's very cool breeding swiffle breeding habitat suitability model. He could give a whole hour-long talk on this. I'm going to spend 2 seconds on it. Essentially, what he is considering is Landsat-based information, DEMs, thematic mappers, vegetation, and signatures to that like, and predicting where the highest suitability would be. The color coding here is green being the highest, red being the lowest. Essentially, in this view, it's correlated with the vegetation stands, which of course is mostly tamarisk, and that's where swiffle are being observed, where SRP is monitoring, and Matt Johnson, as part of this project, also did some field measurements. Okay, so sorry that was 2 seconds of Jim's very cool model, but let me skip ahead to where we synthesize all this together, and we get, well, where are the suitable areas? Okay, outside of the flood reset zone, potentially suitable nesting habitat, and it's not just swiffle. There's other birds and other wildlife to consider as well, and vegetation considerations. So we get this big green blob. Okay, that's a lot. It's going to represent about half the riparian corridor. That's a lot to get your head around. So let's refine that a bit and focus on those most low-lying areas, probably most likely close to the channel, lower to surface water or side channels, groundwater availability, and also have the highest canopy heights, and using that as a proxy for vegetation growth potential. Okay. And we get these pixels of purple, and then we made a less strict criteria for what we call a medium priority. So we have a high restoration priority based, again, on those low-lying areas, high vegetation productivity, and then a medium, which is not quite as low-lying, but fairly low-lying and not as tall. Of those purple and blue dots, we want to consider those groups where where they cluster with at least 10 acres in size, using that as kind of a proxy that's about the minimum of what swiftfowl habitat would need. So in summary, all potential priority areas, they represent a little less than half of the total riparian corridor from the box all the way down to past Fort Thomas. But we want to focus on the high and the medium, and together they account for 750 acres, which is a much more manageable size for rapid active restoration. We're talking active restoration here. I skipped past where you can consider passive restoration, particularly in areas that might have a high scour potential, flood scour potential. But the recommendation there would be to wait for the next flood to come through, do the work for you in terms of tamarisk removal, and then just like a wildfire, take advantage of that, and then you could apply some plantings there before the tamarisk reestablishes. That would be a passive approach. Again, we're primarily focused on the active approach, and 750 acres is definitely more manageable to consider for active restoration in 2014. Okay. And now what the Gila Watershed Partnership is doing is they're reaching out to landowners. Most of this valley is privately owned, agriculture, cotton, a few other crops. And this is just a quick overlay of the parcels in the county and identifying those that have where there's occurrence of the highest restoration potential. And they're in that process right now. So we're not done. This is a work in progress. Let me quickly re-summarize our hydrological approach, eco-hydrological approach. Again, the riparian corridor, flood considerations, vegetation, water availability, salinity, Jim Hatton's swiftfowl modeling, refining it down to those low-lying areas, higher vegetation growth potential. And let me just go back. And so that's where we're at with site selection. Okay, so again, this is in progress. We're not done. We need to factor some more information. What the science team is currently working on right now, we need to consider more of the swifting nesting habitat that has been surveyed out in the field. Jim Hatton is doing more really cool modeling, but instead of Landsat, he's going to use the LiDAR data and other remote sensing that was collected for this project. So that's forthcoming. We'll see how that compares. It may not make a difference, but it could. We hope it will. Continue groundwater and biocontrol monitoring through the spring. And of course, inform on the appropriate planting mixes. And the Gila Watershed Partnership has got a really cool greenhouse. So if you need plants in eastern Arizona, talk to Jan Holder, somewhere, I think. And speaking of Jan and Bill Brandow, another member of the partnership, they are dealing with the human element that we are completely blind to, which is equally as important. So they are reaching out to the landowners, talking to them about these opportunities, looking for possibly other opportunities, consideration of water rights, which is very important in this valley, infrastructure protection, flood protection is a big one. There are levees, there are some diversions that have to be protected, there are bridges, there are the town of Safford, and then initial cost and long-term maintenance needs. Okay, so with that, my throat is better. Thank you for bearing with me. And I'd like to acknowledge, of course, the Gila Watershed Partnership for facilitating this work and bringing us in. It came from a very generous grant from the Walton Family Foundation. Our science team at Desert Botanical Garden, NAU, UCSB, USGS, and at Utah State, our very diligent GIS staff who did a lot of the mapping, and our field support, Devin Orr and Dan Kepke, and of course, lots of assistance and good conversations with these folks, Tamarisk Coalition, Cross Watershed Network, and Tawny's group at Southwest Decision Resources. That's it. Thank you.
I just missed the purpose of the restoration project on the Gila River. I mean, we've heard that there's a very natural flow regime there. Was it just for restoring southwestern Willow flycatcher? You guys have a lot of great information, a lot of it's cool, this work that you're doing for prioritizing. I just missed what the purpose was, I guess.
Sure, I probably swallowed those words in between coughing. Yeah, it's because this is a tamarisk-rich area. I mean, this is a dominantly tamarisk area, and of course there are water-saving issues that might be driving some of this, but it's primarily in anticipation of the eventual arrival of the leaf beetle, which will, you know, just like it's doing on the lower Virgin River that Bruce Orr will talk about next, in other places in the Southwest, it will have impacts short-term on habitat. So in anticipation of that, let's get ahead of that and get a good restoration plan, a science-based restoration plan in place. Grab all the available information we can so we have informed decisions on getting tamarisk treated strategically and native vegetation back in there so that any short-term impacts could be essentially, think of this as advanced mitigation or advanced restoration before the beetle gets there. Yeah, and swiffle is the big driver. Cuckoo are out here as well, and there are other species, but swiffle is one of the big drivers here.